For this week's lab, we'll be chasing wheels of cheese down the hill behind Engineering Hall. Just kidding. We'll be doing something much more fun. We'll be doing a topo of the hill behind Engineering Hall. A topo is short for topographic map. We'll be collecting coordinate and elevation data with total stations and using the data to create a contour map. First, you'll need to set up a total station in a location where you can get a clear shot of at least 2 control points and also get a good view of the hill. Follow the instructions of the previous video on total station setup. Make sure you print out the lab instructions so that you know how to operate the total station. Measure the height of the total station with a tape measure. Measure up to the star on the side. You'll also need to measure the height of the rod. Measure up to the center of the prism. After you've entered the temperature and pressure and tilted the scope, press the menu button to select files for control and data collection. Select Job to open the Job Manager. Select the file named Control and press the DSP button to designate this file as the control file. This file contains the coordinates of the control points used to establish the total station's coordinates and azimuth. Next, select the file corresponding to your lab number and hit Enter. This file is used to store the data points measured during lab. Hit Escape to return to the basic measurement screen. Now that the correct files are selected, you will need to establish the total station's coordinates by siting 2 different control points. After measuring the distances from the total station to the 2 control points, and also the angle between the 2 control points, the total station can calculate its occupy coordinates and azimuth. The total station will need to know its own coordinates and azimuth so that it can calculate the coordinates of the measured points used to construct the topo. Setting the total station on an unknown point and using 2 known points to calculate its coordinates is known as the resection method. A list of available control points is provided in the lab handout. The control points are small metal discs that are set in the ground. They'll be marked with small flags so you can find them easily. A unique number is engraved on each control point and corresponds to the numbers given in the handout. First, press the STN button to enter the station setup menu. Select the second option, Resection. You'll then be prompted to input the first control point. You're free to use whatever control points you'd like. Enter the name or number of the control points using the keypad. Press the Mode button if you need to switch between using letters and numbers. Enter the height of the rod where it says HT. You'll then be prompted to site the back sight and take a measurement. Have the rod person move to the control point that you've selected. There will be a small indentation or mark on the control point. This is the exact location where measurements should be taken. Set the tip of the rod exactly on this point. Use the bubble level on the rod to hold it as straight as possible. This will reduce measurement error. While one group member is holding the rod on the control point, you'll need to sight them using the scope. First, use the small finder that's on top of the scope. When you look through the little finder, you'll see a small triangle. Use this to get the scope roughly close to where the rod is. In order to rotate the total station, you'll need to rotate the coarse vertical and horizontal locks to unlock the total station and allow it to move freely. After it's unlocked, you can just rotate the total station with your hand. After you're roughly close, look through the scope and center the crosshairs exactly over the center of the prism. Use the fine adjustment knobs to rotate the total station in small increments. The coarse rotation knobs have to be locked in order to use these though. The scope image will likely need to be focused. Use the large knob that surrounds the scope to focus the entire image. Use the smaller knob surrounding just the eyepiece to focus just the crosshairs. This will reduce measurement error. When the prism is sighted and the image is focused, press the MSR1 button to take a measurement. When the measurement is complete, you'll be prompted to enter in a new control point. Enter in the name of the second control point, have your rod person move to that one, and then take another measurement similar to what you did with the first control point. When you're finished with the second measurement, it should display the coordinates of the total station. Hit Enter to record the coordinates, and then hit Escape to return back to the measurement screen. You're now ready to start taking topo shots. Get some shots of the sidewalk going up the hill. Also get some shots of other objects like trees, light poles, and of course, cannons. Also, you need to be aware of how your data points are going to represent the terrain. You'll basically be interpolating the terrain between data points, so make sure you get shots where the slope changes. These points are called grade breaks. If you don't get shots at these locations, you will interpolate incorrectly and get an inaccurate representation of the terrain. Try to take as many measurements as you can that are spread out from each other. You may be pressed for time, so try to be quick and efficient. Develop some sort of hand signal to tell your rod person to move on. To take measurements, you'll use the basic measurement screen. It'll display the horizontal angle, vertical angle, and slope distance. Sight your rod person at the new point and press the MSR1 button to take a new measurement and update the slope distance. You can actually use different screens that will give you different information. Notice the 1/4 in the upper right hand corner of the screen. This means that we're in the first of 4 available screens. Press the DSP button to move to other screens. For example, the second screen displays the horizontal angle, vertical distance, and horizontal distance. Use these screens to your advantage so that you can catch mistakes. For example, if you're shooting a point uphill, the vertical distance should be positive. If your horizontal angle is 40 degrees, then you should be pointed towards the northeast. If you're satisfied with the measurement, press the record button to save the data point. You'll then be prompted to enter information for the point. PT is the point name. By default, the point number increases by 1 with each recorded data point. The easiest thing to do would be to just name your first point A101. Then the next point would be automatically A102, A103, and so forth. You can then enter in a rod height. Finally, you can enter in a code for the point to help you remember what the point was. The list selection will bring up a list of commonly used descriptions like tree, bush, or sidewalk. You can also select the stack option to choose from recently used codes. Hit enter to record the data point and return to the basic measurement screen and start taking more measurements. Once you feel you have enough measurements or the lab time is up, return to the basement to download your data. Connect the black and yellow cord from the PC to the COM port on the total station. Start up the Conic software located on the desktop and follow the lab handout instructions to download the data and export it as a text file. You can then import this text file into MATLAB and create a beautiful topo map. Just a few final items. Please make sure to print out the lab handout as it contains more detailed instructions for setting up the total station. You'll be lost without it. Also, we'll be going out even if it rains, so don't forget to bring a raincoat and umbrella.